Okay, this video is going to be about Lewis dot diagrams. We're going to go through how to do Lewis dot diagrams for molecules or covalently bonded things, and then also for ionic compounds. Now we don't do Lewis dot diagrams for metallic compounds because metals just share all their valence electrons all throughout the material. They just flow freely, so you never really can pin them down. We wouldn't draw the dots as being any particular place. They flow all the way through the metal. So we're going to start with covalent compounds or molecular compounds. And here are the directions that we should hopefully already have in our notes somewhere. And what you really need to remember is that this is non-metals only, right? If you have something that's just non-metals, this is what you're going to do. Now, covalent, sharing is caring. Sharing electrons is covalent bonding. So this is the one where we're going to show sharing. That's why we show bonds between atoms as lines, and every line uses 2 electrons. So here we go. We're going to add up our total valence electrons. We're going to figure out what element goes in the center. If it's difficult to figure out, it's usually pretty obvious who goes in the center. We're going to use the electrons first in single bonds. Then we're going to fill octets for atoms from the outside to the center. Put dots on the outer atoms, make them happy first. Then if you still have dots, put them on the center. And then this is very important. Some of us do this too early. Make double or triple bonds if needed, as in only make double or triple bonds if you run out of electrons. Okay, let's do this for phosphorus trifluoride. They're both nonmetals. They're both to the right of the staircase, so I know that this is going to be covalent. Okay. Phosphorus has 5 valence electrons, and each fluorine has 7. I'm going to have 26 total valence electrons to work with. Okay. Seems pretty obvious that the phosphorus goes in the center. I'm not sure exactly where the fluorines go. Maybe I just spread them out, doesn't really matter. Once I figure out the dots, then I'll really know where the fluorines go. Okay, now I'm going to use 26 electrons. Single bonds first, dots on the outer guys, and then dots on the central guy if I still have some. So here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I still have 2 more dots. I haven't got to 26 yet, so go ahead and give them to the phosphorus. He wants them. Everyone has an octet without needing double bonds. Every guy here, each fluorine has 6 dots and then the bond, so 2, 4, 6, 8. He's got an octet. And the phosphorus has 2, 4, 6, 8, so he's got an octet. I would probably redraw this, knowing that the dots on the phosphorus push the 3 bonds down into a triangular pyramid. Okay, now let's do an ionic. Here's barium chloride. Totally different process for ionic because I need to have the nonmetal steal electrons from the metal. For ionic, it's a transfer of electrons. So let's show them with their starting valence electrons. Barium has 2 on the outside, and each chlorine has 7. Now they both want octets, but chlorine is going to get the octet by gaining electrons. Barium is going to get his octet by losing all his valence electrons, so it'll look like he has no dots, but we know he has an octet hiding in the layer below. So that's why we need 2 chlorines, because 1 dot is going to be stolen by that chlorine, non-metal, steals from the metal. Now he's done, because he's got an octet. That's why we need this guy. He's going to steal the other dot. When I draw my final version, Each chlorine will have 8 dots, 7 that he showed up with and 1 that he stole. And because each chlorine stole 1 electron, he each has a -1 charge. This barium lost both his dots. Losing 2 electrons gives you a +2 charge. This is how it should always end up. The metal should end with no dots, and the nonmetal should end with 8 dots. And here's my ionic compound. It's not showing sharing. Sharing is for covalent. This shows stealing.